Well, dear students, now in this video I am going to explain you how you can prove laws of refraction from his theory. Here in this figure, this Z dash is the interface between two medium which I have written as medium 1 and medium 2. AB is the plane wave front traveling towards Z dash with the speed c1 in medium 1. It strikes the boundary or interface between medium 1 and 2 at angle I. Actually, this is wave front. Normal to wave front are raised. Here is the normal, this is angle I. This will be 90 minus I. So this will be I. You can prove it. Here similarly, this is normal, this is reflected ray, I, this is R, this is 90. So this is 90 minus R, this is 90, this is R. Now how to draw this figure? ये बच्चों के लिए this is problem for students. And I am telling you because there is concept, wrong concept in the brain. I am stressing again and emphasizing, please understand what is wave. So we keep on thinking some wrong idea. I have told you that wave travels straight. So this is normal to the wave front are raised. And what is wave front? The point, the locus of point in which particles oscillate in same phase. So to draw this diagram, what we do? Actually, the wave front A has striken first. Secondary wavelet from boundary will get reflected as well as refracted. We are not interested in reflected wavefront. So, suppose and B strike B dash in time t. So, in time t, the speed distance covered by BB dash, that is BB dash will be here C1t. Will be C1t. But in this time t, here A dash is equal to C2t because here speed is different. So what we do, we take point A center, take radius C2t, draw an arc and tangent from B dash to this, give the refracted wavefront. So B dash A dash is the refracted wavefront. So you can describe figure yourself that Z dash is the interface between medium 1 and 2. You write yourself medium 1 and 2. Z dash is the interface between medium and 2. Plane wave front AB, incident at angle I. Normal to the wavefront are raised. So this is one ray, this is ray 2. And A of the wavefront has striken the interface earlier than B. B will strike at suppose later time t. In that time t, the secondary wavelet from point A will go a distance A dash equal to C2t. So to find reflected wavefront, we draw an arc taking a center A dash radius and tangent from B dash to this gives you the reflected wavefront. Here I have taken medium 1 rarer, this is denser. But one year there was question to draw the refracted wavefront when light is going from denser to rarer medium. So how to draw? I am telling you how to draw. This is the boundary Z dash. हाँ भाई थोड़ा ये ऊपर हो गया. Sorry. Boundary Z dash. Incident wavefront. Here mean speed is less. So you take like this. AB. Incident wavefront. Now, basically, you know, here speed more than, and then normal here. This is normal here. This is angle of incidence. This is also I. Since in denser, it is denser medium, it is rarer. So now speed here will be more. तो अब जो B dash C1T, तो now actually the distance C2T will be more than C1T. तो योर वेव फ्रंट बिल को एक्चुअली पहले ही बना लीजिए इसको ऐसे, ये पहले एंगल रिफ्रैक्शन पड़ा होगा इंसिडेंस से. तो यू ड्रा एन आर्क टेकिंग रेडियस C2T longer than BB dash. BB dash से लंबा आर्क लेंगे आप ये, एंड देन ड्रा टेंजेंट हियर. तो दिस A dash B dash now will be reflected wave front. Here this is angle I, this is angle R. This is angle R here now. This is the tangent here, this is angle R. This is I. So when light go from rarer to denser rarer, a ray bend away from normal. So you can draw this diagram like this. ये भी जरूरी है जानना, है भाई. Please try it at home yourself. Now I want to prove laws of refraction. Now laws of refraction, you know, incidence ray, refracted ray and normal all lie in the same plane. First law. Second law, sin I upon sin R equal to constant which is called index. Now in this figure we will first prove second law. In triangle BAB dash sin I, in triangle BAB dash sin I is equal to BB dash upon AB dash. Sin theta perpendicular upon hypotenuse 90 degree है ना, ये hypotenuse, ये perpendicular, ये base. Similarly in triangle AB dash A dash sin R R ही है A dash A dash upon AB dash. So dividing, so sin I upon sin R, sin I upon sin R is equal to B dash upon A dash. AB dash get cancelled. It is C1T upon C2T. So sin I upon sin R is equal to C1 upon C2. Speed of light in medium 1, C1 and C2, they are fixed value. So C1 upon C2 a constant. And this constant from Snell's law, sin I upon sin R is equal to an index of medium 2 with respect to 1. So n is equal to C1 upon C2. For glass, you know, index more than 1.5. So C2 will be C1 upon n, so less than. So this is the prediction by Huygens theory that C2 is equal to C1 upon n for glass. Suppose this medium is glass, this is air. So glass, index of glass is more than 1.5, you know. So speed of light in glass is less than in air. And this was, I told you in introduction, this theory was given in 1678, but confirmed in 1850 by Foucault when he determined the speed of light in water which was less than in air. And due to this reason, this theory was accepted and the theory given by Descartes was rejected. Corpuscular theory given by Descartes was rejected. Now how to prove first law? Again the same thing. If z dash boundary is normal to plane of paper, then incident wave front, reflected wave front, refracted wave front will all be normal to plane of board or plane of paper, and hence normal to them will be parallel to plane of paper, and hence incidence ray, reflected ray all lie in the same plane. You can make this note how to prove second law, first law, sorry. I told you let z dash boundary be normal to plane of paper. You in lab you place the glass slab on plane of paper. So the surface of this slab normal to plane of paper. This surface is that on which wavefront fall, and light comes this way. You can see in the glass slab in lab. So that if that boundary normal to plane of paper, then incident wave front, reflected wave front will also be normal to plane of paper, and hence normal to the interface incident wave front, reflected wave front will be all parallel to plane of paper, and hence they all lie in the same plane. So I have told you Huygens's theory. Please, it is little difficult to understand this concept because totally it is abstract in nature. But this is just to explain the propagation of light wave. I told you the difficulty was there. Initially, the concept was there. If there is wave, if there is medium, then there can be the wave can exist. If there is no medium, no wave can exist. Then problem was how the light is coming from sun to earth, because there is vacuum above atmosphere. So then Huygens proposed that theory. I have told you sequence wise the assumptions of Huygens theory and Huygens construction, and then all these things. So I told you later also, we know light waves are electromagnetic wave. In next coming topic, that is interference of light, I will treat light wave as electromagnetic wave. And I have told you while teaching EM wave that it is the electric field vector which produces every effect of light. It is just simply to understand some facts. But I am again telling, I think there is no need to teach this theory. But we are teaching here as a part of syllabus. Nothing more than that. There are some questions which I will tell you later on. Thank you.